Hey A&Pers, this is Dr. Jones checking in. This is A&P1 lecture test for video 5 covering page 6 of the Noteset. So here we have a nice 3D picture of the sarcomere and what it looks like three-dimensionally. The pictures they've been showing us are a slice through the middle of a myofibril to give us the basic concept, and here's what that looks like three-dimensionally. So the M line, as you can see, those thick filaments are all linked medially. And here the H band is only thick filaments, no thin filaments. And you can see that each thick filament has a central core of titin. Here in the I band, you can see is thin filaments only, no thick filaments, but there are the little titins in between, in the centers of the little bundles of thin filaments. And the Z line, where in the middle of the I band, in between two sarcomeres, the end of the sarcomere, but the middle of the I band. And you can see where the little green titins are connected to the actinin of the Z line. And then this one is my very favorite. This is the zone of overlap, three-dimensional picture. And you can see your thick filaments with the central cores of titin. And you can see that there are thin filaments, 1, 2, 3, 4, 5, 6 thin filaments surrounding each thick filament. And if you look at the thin filaments, they each have 3 thick filaments around them, little triangles of thick filaments surrounding each thin filament. So you can see how they're interspersed together so that they can interact. And it is the thick-thin filament interaction, the myofilament interaction, that is the interaction between the actin and the myosin, which does allow the muscle to contract. So let's, on the top of page 6, let's draw a sarcomere. So let's grab, it's not what I want, let's grab our whiteboard, white screen, there we go. Okay, remember, if I can draw it, all y'all can draw it. So the trick here is I don't have a full board, so I gotta remember to draw this small. I gotta remember to draw small. Okay, so the ends of the sarcomere are made of, okay, that was terrible. Okay, wait, no, that's not what I'm, yep. Okay, it's gone. Yep, gone. Okay, let's try again. Screen, white screen, and I think we're still on red. Okay. There we go. So this is a Z line made of actinin. And now we make another one. So the part that faces in, out, in, out, in, out, in, so that these match up. And here's another Z line. And what's attached to the Z lines? Attached to the Z lines are your thin filaments. Okay, let's label that. And the thin filament is made mostly of actin. So the Z line is actin in, and the thin filament is actin, like it's actin out, and the Z line is actin in. Yeah, no, that doesn't work. Okay. All right, and then down the middle in blue. Yeah, okay. Is the M line. and that links the thick filaments medially. So here is a thick filament. And the thick filaments are made mostly of? They're made of myosin, except for the central core of titin. Speaking of titin, it attaches to the Z line. And it keeps the sarcomere aligned. Titin. There we go. Okay, so now let's label things, shall we? So, let's do blue. The length of the thick filaments is the A band. The A band is the length of the thick filaments. Now the part here where there's only thick filaments and no thin filaments is the H band, or the H zone, either way. And then what about the part where it's only thin filaments and no thick filaments? That's the I band. And another one over here. Okay, and we don't have purple. Red and blue make purple. So where there's thick and thin filaments overlapping in the zone is the zone of overlap. Because red and blue makes purple, so I always make this purple. We don't have purple, so we're calling magenta purple. All right, and there's a term that we haven't covered yet. Let's go black. From the Z line to the Z line. So I drew one sarcomere. That's the right term. There you go. Sarcomere is from Z line to Z line. So now that we have that drawn out, let's quiz. What is it called from Z line to Z line? A sarcomere. What is the length of the thick filaments? Anywhere there are thick filaments, it is what? A band. Anywhere there are not thick filaments is what? I band. What if there's only thick filaments and no thin filaments? H band. What if there's only thin filaments and no thick filaments? Still the I band, right? It was a trick question. What if there's both thick and thin filaments? The zoo, the zone of overlap. So what is the zigzag called? A Z line. And what's it made of? Actinin. What is attached to the Z line? The thin filaments. And what are they made of? Actin. What's the line down the middle? The M line. And what's attached to the M line? The thick filaments. You got it. Ooh. What is the central core of the thick filaments that extends to attach to the Z line that keeps the sarcomere lined up. The titin. You got it. Did I ask what are thick filaments made of? What are thick filaments made of? Myosin. You got it. Okay, there is no part of this that I have drawn and asked about it that you do not need to know in your sleep. Memorize it, draw it, memorize it, draw it, check your spelling. Because this is both lecture and lab material. This is need to know. Okay, so this was what goes here on the top of what for me is page 6. This is the drawing you want and the labels. And make sure you put in that the thin filaments are mostly actin, the thick filaments are mostly myosin. Okay, so here's the same thing that we just drew. See, you've got the zigzag, which is the Z line, and it's made of actinin. From Z line to Z line is a sarcomere. The length of the thick filaments is an A band. Where there are only thick filaments, no thin filaments, is the H band. Line down the middle is the M line. We already did Z line, didn't we? What is the red line? Thin filament, and it's made mostly of actin. And then the blue line is the thick filament, and it's made of myosin. What do you call the thick and thin filament together? What is the classification of that type of filament? I'll give you a hint, it's in muscle. That's right, myofilament. The thick filament and the thin filaments are muscle filaments, and myo means muscle. And they are proteins. They're structural crystalline proteins. I know it's crazy. Okay, and the thick-thin filament interaction is muscle contraction. And did I ask about the green? The green? Tighten. And thick and thin filaments. The zoo. And what's this part with thick and thin filaments? Also a zoo. And what's this part where there's thin filaments but no thick filaments? And this part where there's thin filaments but no thick filaments? I band. All right, so here it shows the thin filaments attaching to the Z line along with the springy titans. And so here is the whole picture of what the thin filaments actually look like. So the 4 proteins of the thin filaments, and I'm going to change pen color. I can remember how. No? There. Yeah, no, that's the right. It just wouldn't cyan doing it. Troponin, nebulin, tropomyosin, and actin. We've got 2 different types of actin, but they're the same, sort of the same thing. Let's draw a picture of it. Let's draw this picture for ourselves. You can see that the 2 strands of actin coil around the central nebulin like a double helix, like DNA. I can't draw that. So I'm going to show you how to ignore that part and draw it without that bit. My coffee's a little cold, but it's still caffeinated, so we're calling it good. All right. The nebulin tends to be blue on the picture, so the central protein rod is called nebulin. There you go. And it has globs spheres of actin. And these spheres of actin are called G-actin. And the G is for globular, which means like glob, or more specifically globe, like a globe, like the planet, like a sphere. So the G-actin means that these are spherical molecules of actin. So they're little balls of actin. So 1, 2, 3, 4, 5, 6, 7. I'm going to draw 7, and for a reason that we'll hopefully remember to cover in a second. It's not a test question. It's just the way they're built, and why not? 5, 6, 7. You know those videos where the professor gets up and draws a perfect circle? This is not that video. That's not happening. Okay, so there's kind of two poles of each G-actin. There's the end that's attached to the nebulin, and then there's the opposite end of the sphere. Okay, so the opposite end of the G-actin, the yellow doesn't show. I can't label this in yellow, and we don't have orange. Okay, I'm gonna make these gray. They're orange in the book. And these are the attachment sites. I have them. These are the active sites. Excuse me. Okay. I think we're okay. And it's on actin, so it's the active site on actin. And they will each have them. Give me a second, I'm drawing these in. If you want a better picture, there's pictures in the book. On the plus side, if I can draw it, all y'all can draw it. Okay, so the active site is the, I don't know, maybe quarter of the sphere furthest from the nebulin. And the active site is also called the myosin binding site. Slash active site, okay? And that's because myosin binds to it. And we know that we want the myosin and the actin to interact to make a muscle contraction. Well, what about if you don't want a muscle contraction? Most of the time, most of your muscles aren't contracting. There's always some contraction, especially in the postural muscles that keep you upright and, you know, breathing. So there's always some muscle tone in each muscle, but the majority of the muscle is most of the time not contracting. So to keep it covered, I forget what picture it is in the book. Okay, we're going to go with green. So we have this protein that sits on top of the active sites and covers them so that the myosin can't bind to them. And this is called tropomyosin. The tropomyosin covers the active sites on actin so the myosin cannot bind to it when you don't want your muscles to be contracted. If all your muscles were contracted all the time, you'd have spastic paralysis. You would be unable to move because you'd be fully contracted all the time. You have to be able to uncontract one muscle so you can move. Okay. So what holds the tropomyosin in place? We need another color. We did white won't show, yellow doesn't show, we did gray. Okay, we're going magenta. So this next one has 3 parts. One end attaches to the tropomyosin and one end attaches to the G-actin. Oh, and these tropomyosins are 7 G-actin long. That's why I always draw 7 G-actin. So I only have to draw 1 tropomyosin. If I did 14, I'd have to draw a second one. With a second, what holds it in place? Troponin. So the troponin attaches to the G-actin and it attaches to the tropomyosin. So it holds the tropomyosin. So here's my row of active sites on my 7 G-actin, and here's my tropomyosin covering it. And the troponin is what holds my tropomyosin on covering, inactivating the active sites on actin, on the G-actin. Oh, we didn't cover F-actin. Let me go back 1 second. Okay, the whole shebang is an F-actin, and that means filamentous. And a filament is a thread because these are long, skinny threads of actin. F-actin, G-actin, I'm probably never going to ask you a question about that, but it is on the picture and it's confusing because the little balls of actin and the thread of 2 strings of balls of actin attached to the nebulin are all called actin. Okay. So that's how that works. Okay, so the troponin holds the tropomyosin on the active sites on actin. That's where we were. So there has to be a key to open the lock. Troponin is the lock that holds the tropomyosin in place so that the myosin cannot bind, so that your muscles aren't contracted all the time where you can't uncontract them, okay? So what's the key? Pen color. Calcium. Calcium ions are the key that unlocks the troponin. So when 2 calcium ions bind to each troponin, that changes the shape of the troponin, and then that pulls the tropomyosin off of the active site on actin. Green. Okay, so the calcium binds to troponin, it changes shape, and then the tropomyosin gets pulled off to the side into that little divot in between the 2 sets of pearls. So the tropomyosins are now on the 2 sides of the nebulin instead of on the active sites on actin. So now the active sites on actin are exposed, and what binds to the active sites on actin? Myosin. Should we draw our next picture? Now let's finish this. Okay, so here's the 4 proteins of the thin filaments. Draw them here. This that I just drew, I'm pointing to the screen that you can't see. That's where you draw that. So under that it says, okay, let's go back to our bye-bye picture. That's a nice picture. You got that one? Okay. So at rest, which protein covers the myosin binding sites on actin? Tropomyosin. And which protein will bind calcium? Here you can see it holds it on. And change shape, pulling the tropomyosin off of the active sites on actin to allow myosin to bind? Troponin. I've already said all of this, but if you need this, just pause and grab all of this and write it down. Okay, so to initiate the contraction, the calcium binds to troponin, which moves the tropomyosin off of the active sites on actin, exposing the active sites on the actin. And that allows the myosin, which is what? Thick filaments. That allows the myosin, the thick filaments, to bind to the exposed active sites, and then they'll move the actin, but we'll cover that here in a second. Okay, now let's talk about these thick filaments. Thick filaments are made of myosin, and it has a tail and two globular heads. Blue. Okay. Tail, a hinge, and two globular heads. That's an N. Tail, hinge, heads. And it's the myosin heads that bind to the myosin binding sites on actin. Okay, thick filaments are made of myosin, which has a tail and two globular heads. The heads bind to the active site on actin, forming a cross bridge. So when the head is attached, when the myosin is attached to the actin, it's called a cross bridge. When they bind, it's called cross bridge formation. And the pivoting of the myosin head is the key step in muscle contraction. It pivots on this hinge, the hinge. And the H band includes a central region where there are no myosin heads. And each thick filament has a central core of springy titin that keeps the sarcomere lined up. And then at the bottom of the page, if you could please draw this. Feel free to draw it better, or fast, or to the best of your ability. All right, that was that page. So that makes it the video. This video is over. So this was A&P1 lecture test 4 video. Was this 5? Yeah. 5 on Noteset 6. Thank you, as always, for tuning in. It's good to virtually see you here. You can do it. As long as you are doing your best, that is good enough for me. If you are not doing your best, get your butt in gear and start learning stuff. Okay. I believe in you. The education must go on. Dr. J out.